Now this one here I've started already just getting a little bit harder, only because of the way that this is written, and here is where we need to factorize. So here we've got our equation, and this is taken from 2a, and with this particular one what we aim to do is to factorize this to change it into this particular form here. So we have to rearrange it somehow. Now we do this by gathering the like terms together and then factorizing. So here we've got an x squared with a plus 4x, and we've got a number down here. We're not going to worry about that for the minute, but that's we'll need that soon. So here, taking the x squared and the 4x, we put them together, and then plus, so this is the line we're looking at for the moment, plus we do the same with the y. We've got a y squared and we've got a minus 6y, taking that and putting those together, and then we've just got the plus 12 equals 0 sitting here. Now the reason we've done this is because we want to try now completing the square. So if we were to factorize this, of course it's not complete, because we would usually have plus or minus something at the end here, but nevertheless, to get this x plus 2 all squared, when you expand that you'd get this. However, watch out, because when we expand this, what we get is x squared plus 4x, and then it'd be this squared, so plus 4. So we've got this extra 4 in here, and if we expand this, we would end up with y squared minus 6y minus times a minus is a plus, so it's minus 3 times minus 3 is 9. So that's extra that's been added in, and we've got this plus 12 at the end here. So this line here, of course, wasn't correct. We had to add more to it. So nevertheless, this line loads into that line and that line, so they're all correct. We're all our algebra is correct so far. Now we need to rearrange. Well, you can see that by doing this we've added in a 4, and by doing this we've added in 9. So what do we do about that? Well, we need to take them out again. So we need to subtract a 4 and subtract a 9. So the way we do it is by keeping this part, because we want to write it in factorized form there. So we keep that, and we keep this, and then we've got our 12, but we have to get rid of this 4, because that doesn't, we've just added that in. So we take away the 4 over here, so now we've got a plus 4 minus 4, so we haven't really added 4 at all. And we do the same with the 9, so we've got a plus 9 and a minus 9. So that takes us to there. Now, what does that get us? Well, we can factorize this like this. So we've now got that. This part here can be factorized, this one here can be factorized like that. And now we add all these numbers here together. That plus that is 13, so 12 minus 13 ends up with being equal to minus 1. That's just my wife washing the dishes there. So now we've got it almost in the form we want. So if we factorize it like this and like this, putting that over there, we've now got this form we had up here, x minus h all squared, y minus k all squared, and equals r squared. So what did the question ask again? It said find the radii and the coordinates of the centres of the circles. So for 1a, that means therefore the circle centre is at the point, now h and k. So what's h? Is it plus 2? No, it has to be minus 2, because remember it's minus h. So if h is minus 2, then minus 2 will give us plus 2, which is what we've got here. And what about the k value? Well, it has to be plus 3, because we need a minus k minus the k value, minus plus 3 is equal to minus 3 here. So it's just 3, so that's the centre of the circle. And what's the radius? Well, the radius is the square root of this number, because remember that's r squared. If that was 9, then we would square root it to get 3. Because it's 1, when we square root it, we just get 1 anyway, so the radius is just equal to 1. 1 what? Well, I don't know. 1 unit. We weren't told with what we were working in. So that's pretty well the way that we do those. Just moving on. Oh yeah, I wanted to do this one with you because it was nasty. So I'm just going to let's have a little play with it first. Just erase all this and work it out together. Okay, it's the same principle. I just did it like this simply because it was a nasty question. This is 1F, 3F, sorry. Nasty, nasty. Okay. So what we've done here is taken this here, and I've thought, well, look at this. This is a nuisance, isn't it, having the 3's there? But that's a factor of 3, that's a factor of 3, that's a factor of 3, that's a factor of 3. Bummer, not a factor of 3. Oh well, we'll just end up with something a bit ugly. So what I've done is divided everything by 3. Now when I do that, what I end up with is 3x squared divided by 3 is just x squared, plus that just becomes y squared. Divide that by 3, 6x becomes 2x. Divide this by 3, that becomes that. Divide 100 by 3 is where unfortunately it didn't work out nicely. So I'll just leave it as 100 over 3. Now what I've done here is taken these values, to shift them across. I actually just love the smartboard stuff, look at that. I've taken these here and done the same thing as we did in the last question. Said, look, we've got x squared plus 2x, so we put that here, gather those two together, gather the y's together to get this. I can just join them by a plus, and left that one where it is. Now again, to get this, that's created by completing a square. X plus 1 squared will give us that. It will, in fact, if I expand that, it will give me that. And if I expand this, it will give me y squared. Now, minus, well, if I expand it out, I'll get minus 3 over 2y and another minus 3 over 2y. So the two of them together will just give me 3y. So that's that. And did you get that? Should I go over how I did this? Notice the x, oh, that should be x squared. X squared, you just put the square root of it there. The number here, though, is half of whatever this is. Why is that? Well, look here. If I take, that'll do, x squared, so if it was a square there, if I wanted to expand it out, I end up with x by x, which is x squared. X times 2, which is 2x. 2 times x, which is 2x. 2 times 2, which is plus 4. So there's the way that we get a 4x in the centre here. So this would give you that plus 4. Now if we forget about that for a moment, if we had this situation, see up here we've got x squared plus 2, and here we've got x squared plus 4. To complete the square, I would write that as the square root of itself, but this one here I just simply put half of that, which is a 2. Alright, now that's not for this problem, that's just the factorization, but that's the way we do it, half of that number. So that's why I put half of that number there, which is a 1. Half of this number here is 3 over 2. So that's how I got that. Alright, continuing on. So, of course that was equal to that, and this one here, when I expand it out, I end up with, what's that times itself? Well, it's minus minus, so it's going to be plus, and it's going to be 3 times 3 is 9, over 2 times 2 is 4, looking uglier, like so. What do we do now? Well, again, we've added in these numbers here. Now notice this time the r is where it belongs, over this side of the equation. So here, this I want to write as equal to that, but I added in the 1, so I've got to take away a 1. Plus this, I can write like that, but I added in this, so now I've got to take that away. It's not gone, it's inside here now, isn't it? That is inside that square. That 1 is inside that, that's why I had to take it away here. Alright, so that's our values there. Now, what do? Well, I'm going to do the same thing to both sides. To get rid of this, I'll need to put it over the other side here. So I add 1 to both sides, add that to both sides, and I end up with this plus this. So that's looking pretty good, because now I can get my h and k. And the other side here, I've just got to tidy this up. It's got 100 over 3. I added that to both sides, and I added that to both sides. So I added 1 to both sides, and I added 9 over 4 to both sides. Now you can just whack that in your calculator if you like. It's pretty easy to do though. 12 is the bottom factor here, so 100 over 12, I had to multiply that by 4 to give myself 400. 1 over, as a number there, is 12 over 12. This one here, I have to multiply both top and bottom by 3, so I get 27 over 12, studying the page. So that's equal to 400 plus 12 plus 27. What's that? It's equal to that over 12. So what's our final story here? What did the question ask? Go back. Sketch graphs of. Okay, well, I'm not going to really spend too much time doing this. Really quickly, I'd be looking at the centre being at -1, and the y value of the centre is at plus 3 over 2, so 1.5. So that's 1, 2, so that's 1.5. So that's the centre of the circle. So there's my circle. Wow, fantastic, hey? With that exactly at the centre, not, but anyway. Will let me shift it, or will it pick it all up as well? Oh, no, see, it thinks it's all one thing. Never mind. So that's the centre of the circle. The radius here, which of course is perfectly even, as you can see that radius is the same in every direction that you go, cough, cough, is going to be the square root of that. So that distance there, all these distances are equal, is equal to the square root of, now it wouldn't be written like that because we can use surds and things, but anyway, we'll just leave it at that. So that's the way that you do this.